in the building. It's so exciting. We've got something new to learn today, all right? We're gonna leave behind the Pythagorean theorem and volume, all right? Although we are going to stick with the coordinate plane. First though, let me show you a couple videos, real short clips from some other people's videos to talk about what we're talking about today, which is functions.
In math, a function is basically something that relates or connects one set to another set in a particular way. A set is just a group or collection of things. Often it's a collection of numbers, but it doesn't have to be. A set could be a collection of other things like letters, names, or just about anything. Sets are sometimes shown visually like this, but more often you'll see sets written using a common math notation where some or all of the members of the set are put inside curly brackets with commas between them like this. A set can have a finite or an infinite number of elements. For example, a set containing all the letters of the alphabet has only 26 elements, while a set of all integers has an infinite number of elements. Okay, so a set is just a collection of things, and a function relates one set to another. But how exactly does it do that? Well, to understand how functions work, it will help if we start by naming the two sets, the input set and the output set. A function is something that takes each value from an input set and relates it or maps it to a value in an output set. And you'll often hear these input and output sets referred to by special math names. The input set is usually called the domain, and the output set is usually called the range. And it's really common to see some or all of a function's inputs and outputs listed in what we call a function table. A function table normally has two columns, one on the left for the input values and one on the right for the corresponding output values. The function itself is often written above the function table and in the form of some sort of mathematical rule or procedure. For example, let's say that the input set of a function is a list of common polygon names like triangle, square, pentagon, hexagon, and octagon. The function itself could be a simple rule that says output the number of sides. That means if we input triangle into the function, the output will be 3. And if we input square, the output will be 4. If we input pentagon, the output will be 5, and so on. So this function simply relates the name of a polygon to its number of sides. That's cool, but most of the functions that you'll encounter in algebra will be a little more abstract than that. They'll usually just relate one variable to another variable in the form of an equation, like this one, y equals 2x.
Functions map a set of numbers to another set of numbers. So what does this mean? Well, say we have a black box. We're going to call this our function. If you put in the number, say 4, you might get out the number 8. If you put in the number 5, you might get out the number 16. For each number that you put in, say x, you'll get out another number, say y. Now sometimes you can put in two different numbers, let's say 4 and let's say 22, and get out the same number, say 39. But at no point in time will you put in one number and get two different numbers out. This may sound complex, but it's really just saying stuff you already know. For example, you use functions every time you go to the gas station. Here, the amount of money that you pay at a gas station depends on the amount of gas that you pump. To put another way, the amount of gas that you pump determines the number of dollars that you pay. So let's say gas is $3.80 a gallon. If you're going on a long road trip, you might need, say, 10.2 gallons. If you pump 10.2 gallons and gas is $3.80 a gallon, the gas station is going to charge you $38.76. If you just ran across town and needed, say, 2.3 gallons, the gas station's only going to charge you $8.74. Of course, depending on your car, you may need more or less gas, and the station is going to charge you based on the amount of gas that you take. Now, how they determine the amount to charge is very simple. They use a function that maps the number of gallons that you pump to the number of dollars that you need to pay. So specifically, we say that the number of dollars you pay is a function of the amount of gas you buy.
All right, that was great. Okay, so I'm gonna do a couple examples of what it is that we're looking at today. First off, I just wanna say that functions, all right, are made up of two parts, all right, a domain and a range. A better way to think about that might be input and output. if you think about that video with the gas tank, all right? But the way we're gonna talk about it most today is X and Y, all right? But these lines gotta get burned in your brain for the rest of your life, all right? Domain, input X, and range, output Y. What am I talking about? Let's come over here and look at it, all right? Make sure I get that set up right. All right. So we've got our trusty coordinate plane, all right? What color am I gonna do this in? Let's do purple over here. Nah, let's do green. All right, our trusty coordinate plane. And I'm gonna give you a series of coordinates, all right? First thing, you're going to graph them. Let's graph A, B, and C real quick. It's not hard. We start at the origin and go over 3 on the x-axis and go up 2 on the y-axis. And we put a dot, we call that A. All right? B is 5, 4. Start at the origin, go over 5 on the x-axis, go up 4 on the y-axis, put a dot, we call that B. All right? Letter C, we're going to go over 6 on the x-axis, up 1 on the y-axis, put a dot, and we call that C. Next, after you graph, we're going to identify the domain and the range. Identifying the domain is as simple as just listing the x values, meaning 3, 5, and 6. That's it. Usually we put them in brackets like this, but it's not wrong if you don't. All right? Usually we put them in order if they weren't already in order. But again, it's not wrong if you don't. The range is just listing the y values, meaning 2, 4, and 1. All right, 2, 4, and 1. I'm going to rewrite that real quick. I'm going to put it in order with the brackets. All right, so it's going to be 1, 2, and 4. All right, 1, 2, and 4. Now, is this a function? A function is a special type of relation where each input only goes to one output, or in other words, where the x doesn't repeat. Does the x repeat here? No. 3, 5, 6. The x does not repeat. So is it a function? You would write yes, because the x doesn't repeat, because each input only goes to one output. Let's come over here, all right, to my orange one. We've got, again, 3 coordinates, x, y, and z. We're going to graph them. X, we go back 4 on the x-axis and up 1 on the y-axis. Put a little dot. Put an X. Y, we go back 3 on the x-axis, up 2 on the y-axis. Put a dot. Call it Y. Z, we go back 4 on the y-axis, up 5 on the x-axis. Put a dot. Make sure I get it in the right spot. Call it Z. All right. Domain. Again, we're just listing the x values. -4, -4, -3. Range, we're listing the y values. 1, 2, 5, it's already in order. And function, is it a function? I hope you already thought to yourself, no, it is not a function. Why is it not a function? It is not a function because that -4 repeats in the domain. All right? If there is an input that gets repeated, it is not a function. All right? If there is an input that gets repeated, there is not a function. There's so many ways to say that. I'll say it in 3 different ways. A function is a relation where each input goes to only one output. A function is a relation where the x doesn't repeat. Or a function is a relation where the input doesn't repeat. All right? So we have 2 things right here. We have a function, A, B, and C is a function, special relation, where the input doesn't repeat. And X, Y, and Z is not a function. All right? It's a special relation. It's not a special relation. I'm sorry. It's not special at all. All right? Function, not a function. That is how we're going to end this little bit of notes. Function. It's a funny word. Circle. And not a function. Not a function. And it gets more complicated than that, but it won't get much more complicated than that today. You're going to be graphing, listing the domain, listing the range, and then telling me, is it a function? All right? Well, sounds good. Y'all want to see the room again? Anyway, time to go. Y'all be good.